Good morning. My name is Maria David MONCAYO and I am here with my classmate Carlos Andres Navia. In this presentation, we will explain how the networks that bring drinking water to our homes are designed. We'll look at their components, the types of design, and the calculation needed to ensure the system works properly. Definition and objectives. A water distribution network is like an underground highway that transports water from treatment plants to our taps. When designing drinking water networks, engineers must first consider several factors, such as regulation and legislation to follow, current and future population to be surveyed, layout of streets and sidewalks for pipe routing, design flows and consumption points, topography of the area, water supply points. Design objectives. This requires adequate pressure. Imagine a 5-story building. If the pressure is less than 10 meters of water column, water won't reach the to flow. Quality pipes must be sealed to prevent soil or bacteria from entering. Continuity. In Medellin, for example, the network is designed to withstand power outtakes by using storage tanks. Main components of the design. Pipes, PVC, used in urban areas due to low cost. For example, 150 milliliter pipes in residential neighborhoods. And ductile iron, ideal for roads with heavy traffic. For example, main avenues in Lima. Valves. Gate valve fully opens or closes the follow. Pressure reduction valve regulates water pressure in lower areas. Hydrants must deliver 10 liters per second, which is enough to fill a 10-liter bucket in 1 second. Storage tanks. In Monterrey, Mexico, the La Huasteca tank stores 50,000 cubic meters of water for a 3-day supply. Types of networks. 1. Branch network. A main large diameter pipe branches off into smaller lines that end in dead ends without connection to the other pipes. For example, rural areas in Colombia where a main pipe splits into a smaller branch. If there is a leak in the main branch, 100 families could be left without water. 2. Looped network. Created by interconnection branches forming loops or circuits within the water distribution system. Found in Manhattan, New York, with pipes from closed circuits. Advantage. If a section breaks, water flows through alternative paths. Mixed network. In Quito, Ecuador, grid networks are used downtown and branch networks are used on the slopes of Pichincha. For test 3 networks types, the attached table shows estimate of initial cost, hydraulic efficiency and redundancy, the existence of alternative routes. Hydraulic design parameters. Water velocity. Minimum 0.6 meters per second if slowed and mildly. For example, in 200 millimeter pipes, it takes 5 minutes to travel 1 kilometer. Maximum 2.5 meters per second. At this speed, PVC pipes wear out faster. Pressure lower limit 10 meters of water column enough to reach a 3-story building. Upper limited 50 meters of water column, like being 50 meters deep in a swimming pool. 3. Head losses. These are calculations to ensure a proper pressure and system operation. To determine head losses, the Heisenberg formula is used.
Hello, my name is Carlos Andrés Pérez. I am a student of civil engineer. Today I will talk about the design process. It's very important learn about this topic, how a civil engineer. The first step is estimate demand. We calculate how much water people need. For example, I can need 1 meter cubic for per day. This dependent on the population, average daily use, and future growth. The second point is draw the network on a map. In this case, we create the layout of the pipes on the city map, connecting maybe the tanks, connecting the treatment plants to all the areas. I'm so sorry. The three point very important is to choose the materials and the pipe size. In this case, the civil engineer can select the type of the pipe. It's possible there are many options, for example PVC, HDPE, or any other material, and calculate the diameter based on the flow and the pressure needs. This is a word for a civil engineer. The fourth point is simulate the system using software. There are many software. For example, EPANET or WaterCAD is very using for the different civil engineers. We calculate how much move through the network. We check the pressure, flow, and heat loss. The 5 point is validate the pressure and flow. The result must meet the required standard. Pressure, then the normal is between 10 and 50 meters of water column. Flow depends enough to supply all the user and emergency needs. This is all about the design process. There are many other points, but this is the most important. And the end of this presentation, the conclusions. The conclusions I can say that the design of the water distribution network is essential to provide clean, continuous, and safe water to the population. Civil and environment engineers, we work together to make this possible. In this case, the civil engineer focus in the design, the layout, choose the materials, and ensuring the system work under the different conditions. The environment engineers take care of the water quality, sustainability, and reducing environment impact. This is very important for all the people. for good quality of the water. A well-designed system ensures proper pressure and flow, safe water quality, efficient service with low energy and water loss. This is very important. Good planning, teamwork with the different civil engineers or the other engineers, and technical knowledge are the key to a successful water distributions network that serves both currently and future generation. This is a work for environment engineer maybe. This is all of this presentation. Thank you for his attention. Bye.